Hello guys, Mr. Middleton here. We are going to talk about writing exponential functions today. After these notes, I'd hope that you be able to, or you should be able to write an exponential function given a graph or given 2 points. Okay, so let's start out. Alright, the two things we need to know to write an exponential function, okay, are the initial value and the growth or decay factor. Okay, or if we're thinking about it as the function, we need the a, the initial value, and b, the growth or decay factor. Okay. All right. So looking at these first two graphs, we're going to be able to write a function given graph. All right. So here, the things we need are a and b. So let's figure those out. Remember, a is the initial value. That means what's happening at time 0. Okay. At 0, when x is 0, our initial value is 4. Right. B is our growth factor. Remember, that's what you multiply by to get to the next number. Okay. Our next number when x is 1 is 5, 6, 7, 8. Okay, so to get from 4 to 8, what do we multiply by? We multiplied by 2. So 2 is our growth factor. That's a little bit of a shortcut. We talked about it yesterday in the notes. Okay? And so now that we have a and b, we should be able to write our function. Our function will be y equals a, which is 4, times b, which is 2, to the x. I'll just keep it like that so it looks like what we've been doing. Okay. We'll do something similar to that with our second problem as well. Okay, again, a is our initial value. What's happening at time 0? At time 0, it's 15. Or when x is 0 is 15. Okay. When we get to 1, our value is 5. Again, this is what do we multiply this by to get here? Well, this is a smaller number, so we're kind of dividing. Okay, to get from 5 to 15, we divide by 3, if that's how you want to think about it. Remember, division and multiplication are about the same thing. Okay, divide by 3 is the same as multiply by 1/3. Okay, so in this case, multiplying by 1/3, dividing by 3. I put in multiplication because that's how you put it in your function. So our function should be y equals 15 times 1/3 to the x. Alright? Alright, so there we go. We've done it with graphs. You're looking at the points. You're going to try to figure out what basically from your initial value, what you multiply by to get to the next number. And that will continue from here to the next number. We'll multiply by 1/3. See, it doesn't come out to be such a pretty number. Okay, continues to do that. All right, so let's write an exponential function given 2 points. Given the point 112 and 236. Okay, and I gave you 2 points from the exponential function, and I just want you to remember that these are coordinates, and so they represent the x and the y in our equations. Okay. All right. And so, what we're going to do is we're going to plug those values in to our functions, and what we're going to have is a system of equations. Except these equations aren't linear. Okay. So basically, what we're doing is we're going to have a system of equations that are exponential. Okay, and that means we have to solve them a little bit differently. So I'm going to write my equations. Remember, we don't know a and b yet. If we did, we'd already have our equation. But we do have x and y, so I'm going to plug those in. So I'm going to start with this point first. Remember, this is x, this is y, this is x, this is y. So y, which is 36 in this case, equals a times b, I don't know what those are, to the x. Okay, x is 2. I'll do the same thing with the other equation, which is 12 equals a times b to the x. Alright, so now I have a system. Okay, 36 equals a times b squared. And what we're going to do with this system, I'm going to write this as a system, put a line between it here. Okay, one of the ways that we solved our systems last time was to eliminate. And that's what we're going to do here. We're going to eliminate one of the variables. Now, because this is all multiplication, this isn't addition or anything like that, we won't be multiplying and subtracting and stuff like that, because that won't do anything for us here, because they won't be like terms. Notice that. Okay. But what we're going to do is we're going to be able to eliminate these by dividing. Okay, and that's why I did this line between. We're going to divide these two equations and be able to get a variable by itself. Okay, so I'm going to go down the line and just divide what's like. 36 divided by 12 is 3. Okay, a divided by a cancels out. Okay, so notice that the a value gets canceled out. Okay, so it cancels out. I have b squared divided by b to the first. We divide those. I'm left with b to the first, if you want to write it that way. Okay, so if you solve it this way as a system and you divide, the a value, remember, because our equation is always a, just a, it's not a to anything, will always cancel out. And so we're able to find one of the pieces. We're able to find the growth factor. In this case, our growth factor is 3. Okay, once we have that, we're able to plug it into our equation and find out what our initial value is. So I'm going to plug it into this bottom equation because it has smaller numbers, and I'm just going to say 12 equals a times 3 to the first. And now I'm able to solve for a. Okay, I'm going to divide both sides of this equation by 3, and I get a equals 4. So now I have a, my initial value, and b, my growth factor. Alright, and so I can write my equation. I didn't give you space to do it, but write it in this spot here. Okay, so is that too low? Yeah, it's too low, I caught it. No, it's still too low, okay. Write it right underneath there. And that should be y equals our a value, which is 4, times our b value, which is 3, to the x. Okay, so notice, even though we're given these points, x and y, in our problem, okay, when we were done and putting it into our exponential function, we left y and x as y and x, because this is what we plug in when we were trying to find out what's happening next, right? Okay, after 2 terms, y was 36. After 5 terms, I don't know what y will be, but I'll be able to plug those values in to find it. Okay? Alright, flipping to the back side, we're going to just do some examples with this, okay, to get kind of more acquainted with it. Alright, so I'll go through the first one step by step a little bit more, and then after that we'll kind of pick up speed a little bit. Alright, so here again we're given those 2 points. I'm just going to write x, y, make sure I keep them together. Okay, I'm going to write the bigger number up top. So y is 96 equals a times b, we don't know, to the x, which is 3. And here I'm going to do the same thing with our second problem. Our second equation, y is 48, a times b to the second. Right? Now remember, we're going to divide this equation, which will cancel out our a's, or get them out of there. 96 divided by 48 is 2. b cubed minus b squared, or divided by b squared. Find that b is 2. So now I have b is 2. I can plug that into one of these equations. I'm going to choose to plug it into this bottom one because it's a smaller number. Say 48 equals a times 2 squared. Okay, 2 squared is 4. I'm going to divide both of these by 2 squared. Just keep it that way so I can cancel this out pretty easy. 48 divided by 4 is 12. And so now I have my a value as 12. I have my b value as 2. And so I can plug it into the equation. Again, when I plug it into my general form, I just have y and x times 2 to the x. Alright? Alright. Going through some other problems. So we'll do the second one first. So I have 5 equals a times b squared. Again, here I have 20 equals a times b to the first. I'm going to divide. I divide 5 divided by 20. I'm left with a fraction, and I'll keep it as a fraction. Okay, it's 1/4 equals a's cancel out b. Okay, so here my decay factor is 1/4. I'll do the same thing now with plugging this in. I'll plug it into the bottom equation. I'm going to do 20 equals a times 1/4. Divide both sides by 1/4, and in that case that means we're multiplying by 4. Right? Because that makes this cancel out. So a will equal 80. So now my equation is y equals 80 1/4 to the x. Okay, do a couple more. 27 equals a times b to the third over 3 equals a times b to the first. Do the division. 9 equals b squared. Now I have to find out what b is, because notice that this other times I were just left with b. Now I'm left with b squared. I need to take the square root to get b by itself. So b is 3. It'll always be the positive number. Okay, so b is 3. I'll plug that in to solve for a. 3 equals a times 3 to the first. It's just 3. Divide by 3 means a equals 1. So my equation, y equals 1, 3 to the x. One more. Got 54 for y equals a times b to the third. 90 for y equals a times b squared. 54 divided by 90, I think that's 6/10, which is 3/5. Whew. Okay. Equals b. Sweet. Again, the a's cancel out, divided by 2. This leaves us with b. Alright, and then I'm going to plug this back into my bottom equation. So I have 90 equals a times 3 to the 5th squared. Okay, so doing some real math here a little bit. 3 squared is 9. 5 squared is 25. Remember, we distribute that when we're raising a quotient to a power. Okay, and so now in order to get this done, we need to multiply both sides by 25/9. That's the same as dividing it by 9/25. Okay, on this side that cancels out, so that works out for us. 25 times 90. Actually, let's see if this, I can do this a little bit better. Okay, that cancels out a little bit, gives us 10 times 25, which is 250. So A is 250. And so I have B is 3/5. I have Y equals 250 times 3/5 x. Alright, so now we should be able to write a function of an equation given 2 points. Alright, we'll get more practice tomorrow. See ya.